Hi. Good. How you doing? So yeah, so we got this thing. So anyway, you can anyway play a video. Yeah, it's all right. Yeah, you can just play. Sorry, you can just play. Well, you guys, thanks for coming, everybody. It's a good turnout. Usually there's like not that many people. Anyway, you guys want me to do the attendance thing, or is that? I don't know. Well, I usually do it. I mean, I usually don't do it, but I started. Yeah, it's like a good enough crowd. So anyway, why don't I do it just to make you guys feel better? I mean, so it did show up. Anyway, so said Thadam, is that how you? Yep. Thadam, right? So said you got your BS degree in chemical engineering?
Masters. Masters.
Oh, masters. Oh, okay. So where did you your
chemical engineering back in India?
Oh, okay.
Yeah.
Okay.
Bachelor's in India, masters here.
Okay. Who did you work with?
Dr. Goulians.
Oh, okay.
Yeah.
So you worked with Goulians.
Briefly.
Okay.
I'll leave it at that.
Yeah. And then you did an MBA?
Yes.
Did you do that here also?
Yes.
Or? All right, so he's like chemical engineer, BS, MS, and then the MBA. And now you're like, what's your role now?
Well, I guess I'll just start
okay.
off. Yeah. Good afternoon, folks. My name is Siddhartham. I work as an energy engineer at UC Utilities, much like you while I was a student on campus. Grad school, chemical engineering. I know all of you are chemical engineers, most of you.
Yeah, everyone's
all chemical engineers. Okay. I recognize a couple faces from a couple other classes, so a lot of the content here is going to be stuff that you've already seen. So either be great with questions since you've already seen all this, or
we did a tour
quite a while back.
No, this year. So I mean, maybe a month ago or something.
Oh, okay, that's nice.
How many were at the tour? Like 8 or something, or? I think there were like 8.
Well, then more people have seen stuff like this, but we do have stuff that was not covered during the tour. But
yeah,
I'm going to be talking a little bit about energy at UC. The idea was to cover power and related things, but I figured I'd give you some context about stuff that's more relevant to you, so you could relate to it. So I guess I'll just get started. Is that okay?
But Goulians does propellants and stuff, right? Or what?
And that's the briefly part that I was referring to.
Oh, okay. Okay, so you don't do. I mean, it seems like an odd.
That's what my research started off in, membrane synthesis. But yeah.
Okay. All right.
Cool. I have a quick video if it lets me play. It doesn't look like it lets. I'm just gonna pull it up on YouTube if that's okay.
Yeah, actually, there's problems in how it made videos. I've had that problem. You probably can solve it.
We'll see.
You can just copy that link that was on the slide. You did the MBA at UC too?
Yes. Yeah.
Are any of you guys thinking about MBA, or some of you are doing MBA at the same time? You can ask me about that too.
Yeah, we could talk.
Once everything's perfectly organized, I'll start working on my thesis.
Energy generation at the University of Cincinnati goes way back to the year 19.
Okay, that is slow. I usually start off with a video. This is a more recent video, so those of you who were at the plant at the tour or in the class, I don't think you've seen this one. So I'll start off here and then we'll jump into all the other stuff.
The video at all.
Did not, huh? Okay.
Skip that. I think it's real late.
Come on, just play it like that.
1910. Energy generation at the University of Cincinnati goes way back to the year 1910, when the power plant was first built on campus. We only had 800 students back then. In 2004, the central plant expanded to start producing up to 100% of the electricity needed as well. Today, we have over 48,000 students. Cogeneration alone has saved the University of Cincinnati $109 million in almost 2 decades. As the university has expanded and enrollment has increased over the years, UC Utilities has been laser focused on keeping energy costs down. Utility costs have remained consistent for the past 8 years and are projected to stay flat for the foreseeable future, which most importantly allows the university to avoid tuition increases and helps in dedicating more resources to support healthcare, research, and education on campus.
As we have seen recently, energy prices can be extremely volatile and occurs for a multitude of reasons. It was very interesting to learn that natural gas hedging strategies recently deployed by UC Utilities are projected to save $37 million through 2028.
All 4 regional campuses and off-campus buildings have been powered by green wind power energy since 2018, which is going to reduce more than 117,000 tons of emissions by 2024. UC's water reclamation project was recently placed into service, and it has helped save 372,000 gallons of water in November alone, and is projected to save more than 5 million gallons annually for just the central utility plant at UC.
We currently generate enough energy to power 40,000 Ohio homes. In recent years, UC has been recognized internationally for all of our energy efficiency efforts. We are really proud of all our achievements and our progress, but at the University of Cincinnati, it is important for us to continue promoting environmental sustainability and keep doing our bit in being better stewards of Earth.
As a co-op in the UC power plant, I not only get to work and learn in the energy field, but I also get to work with people from India, Norway, and Vietnam, which not only gives me perspective on energy practices in other parts of the world, but also adds value to my experience here at UC as an energy professional.
At the University of Cincinnati, tomorrow's reality is here and now.
Next lives here.
Next lives here.
Next lives here.
That was a quick PR type video that we made for an energy competition, which we ended up winning. The idea usually is to, when people tour the plant, have them look at the video, and then it provides some context to what they're going to be looking at, because it's usually pretty loud at the plant. But I figured I'd also add it here so that we could talk about it and then move on. Okay. Like I said, much like all of you, I was a student on campus, and as a student, didn't necessarily care about utilities. All I cared about was when's the next pizza party, because I don't have the time to cook. Got to get back to my lab to eat, have homework, assignment, research, etc., etc. So never really cared what happens behind the scenes. And lo and behold, I start working on campus. I'm like, not only do we have 1 power plant, but we have 2. Central utility plant, which is right across campus on the other side of Morgan, Scioto, and Spencer Hall, and East plant, which is on the medical campus, right in front of Eden Garage, right by the MSB Care building. It's not the case that Central plant provides power to this part of the campus and East plant over to that part of the campus. That's not the case. Both plants operate as a single entity, as one utilities, if you will. And I don't know how many of you know, but the plant used to be where the current rec center is. And yeah, I see some raised eyebrows. Yeah, I was surprised too. Turns out, like the video said, we've been generating energy on campus for 100+ years, a long time. The plant was where the rec center is on the other side of the Nippert horseshoe. And as the campus was growing, they decided to obviously generate more energy because the campus needed more energy for all sorts of stuff happening on campus and to accommodate for the increased enrollment. So they're like, okay, so if we have to grow the plant, we have to do a few other things. We need more space. Campus needs other services, stuff like the rec center. So we'll just move the plant off campus. And the central plant is where everything from the rec center got moved to, which is right by USPS Domino's. You might have been there, driven past where this is. They used to do just steam generation and chilled water generation for quite some time, and UC started generating power almost 20 years ago, just started way back in 2004. So coming up 2 decades on it. But this was just to give you a little bit of a perspective on how transformative the campus has been over the years, and the energy part of it also has been impacted by the transformation that campus has seen. We have the ability to purchase electricity, but we generate up to 100% of the electricity that the campus needs. We also are responsible for generating steam and chilled water for all of the campus buildings, regardless of the time of the year. Obviously, research happens, so the research labs have to be maintained at certain temperatures. One of the things I learned was the CCM buildings have to be maintained at certain temperatures and humidity levels because the instruments apparently like it that way. I was told that one of my colleagues at the plant got a call from somebody at CCM saying that the harp strings were not taut enough because there was a lot of condensation on the strings. And that threw off a bunch of stuff. And I'm like, when was the last time people put energy in the perspective of somebody from CCM? Interesting. So responsible for electricity, heating, and cooling the campus. We also manage water within campus boundaries. Cincinnati Waterworks brings water up to the campus, and then everything that's on this side of the boundary, UC Utilities manages. We also have a couple thermal tanks, which I'll get into in just a bit. Some of you may already know about it, but these are just large tanks. Call them large refrigerators, if you will, that just keep water cool. They just happen to be big enough to store 4 million gallons of water. The one on the main campus and the other one under the east plant, literally under the east plant, is as big as a tank that could hold almost 3 million gallons of water. What that is, we'll get into in just a bit. The idea is to not necessarily talk about numbers and the technical stuff, but more about policies and why UC makes certain decisions in the energy realm the way it does. Again, putting my student hat on, I'm like, why do we not have buildings covered with solar panels? That seems to be the easiest thing to do. Why do we not do it? And lo and behold, I start doing all this. I'm like, okay, makes sense. The thermal energy storage tank that we have on this part of the campus is under the practice football field. Used to play ultimate frisbee on there, did not know we had a tank big enough to hold 4 million gallons of water. And I'm like, fascinating. More on that in just a bit. When I was a new student on campus, I was a part of a UC Myths and Legends tour. I met somebody from DAP the other day. We're like, oh yeah, I was a part of Rower Tour Guides and I used to do all that. And I'm like, interesting. They told me that UC has tunnels when I was a new student. They were like, oh, by the way, they also have dolphins and they experiment on dolphins in these tunnels. Those of you that have heard this joke know where I'm going with this, but sure enough, I started working in this role at the plant. One of the things I have to do is walk these tunnels on a monthly basis and take meter readings, energy readings from meters that don't communicate energy consumption automatically. And sure enough, I'm like, oh, the tunnel part was real. Dolphin parts not so much, just haven't seen any. But the tunnel network is extensive, gives me a certain appreciation for civil engineering and planning and design, because all of this had to be planned way back in the day. And even though the plant has moved across the road, all of this has been retained. And the tunnels under the rec center still serve as the distribution system. So energy from the plant gets over to the rec center part, of the campus, and then from there it disperses to various parts of the campus. Again, usually people like civil engineering is pretty impressive. I was also told that the tunnel network is so extensive that you could start under the old law school and end up on the East Campus almost entirely underground. Haven't done that entire stretch, but I'm like, okay, so I guess we do have a decent amount of tunnels. In addition to all the campus buildings, we also supply energy to the hospitals in the area. One of the questions I usually get when I'm hosting plant tours is that, hey, Sid, COVID happened, nobody was on campus. Were you offline? Did you shut down? But actually, no. That's when we were extra busy because hospitals were extra busy, and we wanted to make sure that energy was supplied to the hospital as much as possible. Yes, there was a little bit of research going on campus. Water-cooled equipment still had to be water-cooled, so we had to generate chilled water regardless of how cold it was. But we had to supply energy to all of the hospitals, so we were up and running 24/7. We still are, regardless of what happens on campus. This cannot be impacted, so the plants have to be up and running all the time. A quick overview of the type of equipment that we have. Let me start actually up top. We used to burn coal, I want to say until about 10 years ago. All the coal burning equipment has since been done away with, and now our primary source of fuel is natural gas. We burn a decent amount of natural gas. I'll start with the central plant. Electricity is generated only at the central plant, heating and cooling at both central and east. We have two combustion turbines. That's the CTG 1 and 2 that's on the screen, right? Oversimplified, natural gas in, turbine spins, electricity out. Operates on pretty much the same principle as a jet engine, if you will. If you had a pinwheel and we were to blow on it, same thing. At a simple cycle plant, natural gas in, combustion turbine generates electricity, and there's a lot of heat that's a byproduct of that process. And at a simple cycle plant, that heat would just be exhausted. What happens here, though, since we're a cogen plant, a combined heat and power plant, we capture that heat and recover it with our heat recovery steam generator, so HRSG, what we call, and that heat could be used in two different ways. We can either use that excess heat to generate high pressure steam and therefore spin a steam turbine and generate more electricity, or just use that steam to heat the campus, in which case we don't have to run boilers, therefore we don't have to consume more natural gas, therefore less carbon emissions. We could either use that entire heat to solely generate electricity or to solely heat the campus, or mix and match depending on the time of the year, depending on the demand, so on and so forth. So that by default puts us at a very high efficiency compared to a regular regular simple cycle plant which just generates electricity. Like I said, steam generation happens at both on both sites, both central and east. We have two boilers at central utility plant and two boilers at the east plant. Again, oversimplified, natural gas in, steam out. I'm sure you folks have studied all this before, so you might, I don't want to go into details. In addition to that, we have an extensive fleet of chillers, almost all electric chillers. Overall, all electric chillers at the central plant and two natural gas chillers at the east plant. So if you were to look at the plant buildings as just plain buildings, we're the highest consumer of electricity at UC, simply because we have to consume electricity to generate chilled water to cool the campus. Any questions so far? Yes.
How do you use natural gas to chill?
Natural gas to generate the electricity. That electricity eventually runs the chillers, which generate the chilled water, which cools the buildings. So the two sources of energy into the plant would be electricity purchased directly from the grid and natural gas burnt at either plants. A quick visual of the combustion turbine. I'm pretty sure that looks familiar, like the bottom end of a rocket. Quick visual of the steam turbine. Like I said, the high pressure steam which is generated from that heat that's recovered is then in this way spins all these turbine wheels, and there's a generator that's on this end of the turbine, which sends out the electricity to the substation that we have right by Domino's. So if you've lived on, I think in Morgan's, you might be you might have seen the plant on the other side of the road. Quick visual of thermal energy storage. How many of you have heard of TES before? Couple of hands. Okay, sweet. I'll get into why this is important from a financial standpoint, but the idea is we generate chilled water during the night and fill it up with water at 43 degrees average. The next morning, when the campus starts and the campus opens up, people start getting on campus around 8 o'clock, 9 o'clock, whatever that is. That's when the cooling load picks up. That's when people start needing more cooling within the buildings. After a point when it's actually pretty hot, we turn this on, take off the chillers off, take them offline as much as possible to conserve the consumption, which I'll get into in just a bit, and cool the buildings using this tank. Essentially, cold water from the tank goes to the buildings, exchanges the heat, sends warmer water back to the tank at maybe 55, 56 degrees. And that exchange happens until, I don't know, 9 p.m., if you will. And then overnight, that warm water, 56, 55 degrees, whatever that is sent to the chiller. Chiller cools that water back down, and then it's sent back to the tanks. Here's a quick visual of the West tank. And for scale, that's a human being over there. So you could tell that that's a huge tank, huge refrigerator, if you will. Last fall, sorry?
I mean, I see pipes.
That's they are in the tank. That's the tank. No, that's the entire building, if you will. That's yes.
I see. Okay. This would be.
Yeah. So this picture is a little old, but we had a similar situation last fall, no, spring, I think. We found a crack, a leak in that pipe. Obviously, you had to go fix the leak, and the question was, okay, it's full of 4 million gallons of water. What are we going to do? How are we going to fix this? The co-ops at the plant were like, oh, let's get the water level down up until here, and maybe we could send a boat in, and they could get on the boat and try and fix it. Yeah, that's not the best idea. So we unfortunately had to empty the whole tank. But even before that, we had to find where the leak was. So we had a bunch of scuba divers on campus in full scuba gear, oxygen tank and everything. I have pictures which I should have included. And I'm like, who would have thought scuba divers in full gear on campus, and it's not Halloween? Well, it is gonna be now, but not back in spring. But they had a GoPro and everything, jumped into the tank, they found the leak. And unfortunately we had to empty the whole tank. Took us about 2 weeks to pump out all the water. Went in, put in steps to go into the tank from, this is between 60 West and Daniels Hall. There's a hatch that you could climb down. Had scaffolding and everything, they got it done, got the leak fixed, and took us another 2 weeks to fill the tank back up. So you could tell that it's pretty intense work that happened over there. We had to let the Metropolitan Sewer District know that we're going to send 4 million gallons down the drain. Please have everything up and running. We don't want to overwhelm your system. We know you have to treat it on your end, but hey, just FYI. And that's why we had to pump it over a span of 2 weeks, because we didn't want to flood the sewer system. But this was, again, just to get you an idea of the scale of the tank that we have over on campus. Now, one of the things that I found very fascinating was this. You must have heard the video say that we, in terms of energy consumption, we're almost as big as a small town, 40,000 Ohio homes. One of the things I learned was this Duke tariff. What this states is and I'll start with the summer season. This states that during the months of June through the end of September, from the hours of 11 a.m. To 8 p.m., we're supposed to be as self-sufficient as possible. Now, we can import electricity at that point, but it's going to come at a premium. What that means is, if we end up importing anything during those hours, that becomes our new zero. So we'll have to pay for that much electricity for the next 11 months, regardless of if we use it or not. That's like you folks, us, any one of us end up getting $100 Duke bill, and lo and behold, it's $100 for the next 11 months, even if we're out of town for 3 months. We're like, yeah, that doesn't help. Now, 100 is a small number, but that could mean millions of dollars, given the amount of electricity that we need on campus. So the idea is to import nothing during those hours and be as self-sufficient as possible, which means that we need to consume as less electricity as possible. The downside of that is that that's when it's hot, and that's during the middle of the day. Well, it starts towards noon and takes it in up until 8 p.m. and after that it starts cooling down. The problem, though, is that most of our chillers are all electric chillers. So if we have to cool the campus, we need to be able to run the chillers. But to do that during the day, we'll have to import during those hours, which means that we'll have to incur a whole lot of penalties and potential fees for the next 11 months. Now, the alternative to that would be using natural gas chillers, but natural gas chillers are not as efficient. They're more expensive, more carbon emissions, so on and so forth. So to mitigate that is why we have the tank. Essentially, after 8 p.m. and the electricity is cheap, when we're outside the tariff hours, we run the chillers, the electric chillers, we're able to import at that point, and we store chilled water for the next day. It's essentially, if you look at it a certain way, it's a battery. And we're storing the previous day's cheap electricity. Does that make sense? Any questions? So this comes in handy for us to be able to meet the tariff rules and regulations so that we don't incur penalties to the best extent possible. And the grand scheme of things, keep the energy cost down. So that while this is met, the thermal tank is running and cooling the campus. And in the night, we're able to run our electric chillers and charge the tank, essentially fill it up with cold water. That might have, yeah.
How easy is it to keep it at that temperature? What's the insulation like for it?
The insulation's pretty good. It could stay that way for several hours during summertime, several days, a couple of days, maybe even during summertime. Wintertime, it's been that way for at least, from my knowledge, 10, 12, 15 days, if it's cold enough outside. So insulation's pretty good, especially, and it helps the fact that it's underground. A lot of campuses out there have it above ground, looks much like a building. A lot of campuses have put facade around it, so it looks like a proper building, doesn't look like a circular water tank. But ours, it just helps that it's underground. The downside of it is that you have to excavate it, there's more cost involved, so on and so forth. But any questions about this? You might have heard the videos say our regional campuses are all wind powered. Obviously, we don't have wind energy or windmills on any of the campuses. We don't have windmills here. We don't have wind turbines. So we have to purchase and procure wind energy outside from elsewhere, wherever it's generated, and bring it to, well, essentially put it on the grid so that our satellite campuses could import that electricity. And I'm like, why do we not do that for our main campus? And obviously, when I was very new to this system, and I've been doing this for a little over 4 years. Any thoughts on why we don't get wind energy for our campus based on what you've heard so far? Because it'll have to come from the outside and we'll have to import it, and we're not going to be able to import it during that time. So we'll have to be as self-sufficient as possible. So any renewables that our main campus has to consider has to be on our side of the meter, if you will, so that it satisfies our zero import policy to the best possible extent. Now, the downside of that is that we don't have enough land on campus to put in a solar panel, solar farm that could generate enough energy. We don't have enough land to put in a huge wind turbine to generate enough energy. So even if we could do something, we just don't have the capacity to do that. Therefore, we're forced to burn natural gas.
What about the roofs? All the roofs are built.
So we could potentially do that. The downside is, how expensive is it going to be? How much energy can it generate? And is the area big enough to be able to generate meaningful energy to power something decently on campus? Folks are working on doing exactly that, but being able to store it in batteries instead of having to generate and power a building, if you will. They're looking into seeing if solar roofs can eventually be able to charge EVs. But in terms of scale, I don't think we have enough area to generate enough energy to power a building, if you will.
It's right at the green, where you're paying the most, that's where it would generate, right from the daytime.
Yes, but still, it's still not going to be enough from a cost standpoint.
So somebody has looked at it,
I believe so, yes.
because anyway, we had a person come in and said it would be cost effective.
UC person?
No, it's going to.
Yep. Yep. So if the tariff rules don't apply, there are certain conveniences that they can afford. Ours is slightly different. In fact, just a couple weeks ago, we had a solar company in our energy class, and they were like, "Oh, we do this at the zoo," and so on and so forth. Yeah, slightly different pattern of consumption. So, plus most of the electricity we will still need to run our chillers. That's our biggest consumer. And given the ramp up and ramp down of the chillers and when they run, it's a little tricky. I wanted to give you a quick visual of the cost of energy generation.
You can sell back to the grid too.
We can push it back. We're in the process of figuring. Short answer is yes. We've just not been compensated. That part needs to be figured out, but we can put it onto the grid. Yes.
Oh, I thought the gas turbines would power some pretty different too, at those times.
Hospitals, yes. So I guess you could say in a certain way, yeah. So not Clifton. The cost of electricity generation out of the combustion turbine is almost $12 per megawatt hour, or per megawatt in this case. There are a couple other things that further bring that cost down. So this is the cost of electricity generated within UC's boundaries. If we were to import the same 1 megawatt per kilowatt hour in this case, okay, we will have to pay taxes, adder fees, transmission and distribution, because Duke maintains all the wires and everything, the infrastructure between where the electricity is generated and here. So we'll have to pay a fee for that. We don't have to do all that if we can generate energy on site at the plant, because UC maintains everything within campus boundaries. So all of a sudden, we don't have to consider extra on top of electricity generation.
So that's 1 cent per kilowatt hour, roughly.
Yeah, you could say that.
Because it could sound like 10 cents a kilowatt, 10 times.
And yes, in some places it gets 12 cents, something like that. We could do it at a little over 2 cents. I've given other costs that maintenance, et cetera, and comfortably generate enough at 4 cents, depending on natural gas pricing. Again, that changes. So this is based on the cost of natural gas. So if the natural gas price goes up, that's likely going to go up. So on an average, 2 to 4 cents is what I would say UC could comfortably do it at, versus 12 cents per kilowatt hour on the outside if you had to bring it from the grid.
So the regional campuses are paying the 12 cents a kilowatt hour, right, to get the renewable.
No, because we were able to negotiate a cost for the wind energy. So not as high as it would have been. It's something that's contractually changing every now and then, but we were able to negotiate a price which was not as high as that.
But it's still like 5 to 6.
Oh, it is
times.
slightly higher than what
I mean,
main
5
campus
to
was.
6 times higher, right? It's significant.
I want to say that would be close to 7-8 cents. But higher, yes. 5 to 6 times, perhaps.
So that's why you don't use electricity on campus. You have such a huge margin.
Huge margin, plus if we're importing all that, the tariff penalties are separate
Oh, I
on
see.
top of what we'll have to pay. This slide is slightly misleading, and I'm saying that because these costs are from 2 days ago. This graph, on the other hand, is from 2022, but I figured it's good still to put it here so that it lets you look at a few things. This is instantaneous cost of import of the same amount of electricity. And you can see here that depending on various factors in the region, that particular day, I think this is close to $250 per megawatt versus a price at that point. I think we would have been closer to maybe $30, depending on, again, time of the year, price of natural gas. It changes, especially in the summer. It's slightly more expensive to generate electricity, but $15-30 versus $250. And you're like, oh, okay, I guess it makes sense to generate electricity on site, on campus.
So the gas price is just demand, like heat, you're competing against heat, I guess.
Sorry?
People heating their houses.
Yes,
That's the demand.
exactly. So that's that great segue into what I'm going to get into in just a bit. This past December, you probably remember a couple of days before Christmas Eve was super cold. We were asked not to burn any natural gas, curtailed. Price of import of electricity, I remember being a little over 3,000 versus 250 versus 30-40 bucks. At that point, we were curtailed, so we didn't burn natural gas. We had to burn diesel oil, but it was still cheaper than having to import electricity at $3,000. Obviously, we were, I think from a demand standpoint, nobody was on campus, so we were able to generate more electricity and put it on the grid. And I don't know where the compensation of that stands, but depends on the natural gas pricing. Now, given all of that, the production of electricity has gone up over the years. What that's done is it's brought down the purchased electricity over the years, which makes sense because we're producing more, so we're purchasing less. What that's done is brought down the CO2 over the years of purchased electricity. Any questions so far?
You haven't included the gas CO2.
Yep. This is just purchased electricity.
So,
Gas CO2 obviously has gone because we've generated more electricity on campus.
yeah, I wonder how that would sell.
Still downward slope. Going back to your comment and question about natural gas, the blue line is the cost of actual natural gas. Orange line is cost of natural gas plus the transportation and distribution charges, which is essentially natural gas. The cost of bringing that natural gas to the plant. And we've committed to buying a certain amount of natural gas up until, and it says 2028. I think the most recent chart would say FY32, if I'm not wrong. What that means is we've committed to buying and burning natural gas on site for several years down the line. Going back to your question, because the prices were cheap, we were able to lock the prices in at around $3 and say, hey, $3 per MMBTU, we'll commit to paying you that much to be able to burn natural gas. Which initially surprised me because I'm like, isn't everyone going away from burning natural gas and go all green by 2030 and 2035, 2050, so on and so forth? And yet here we are committing to buy natural gas for the next several years. Here's why that's important. Now, given everything that's been going on in the world over the past couple of years, even going back to the whole Russia-Ukraine situation, we'd locked in our prices around early 2021, end of spring 2021, and sure enough, after that, the price of natural gas has deeply gone up. So we had committed to purchasing it at about $3, and I remember seeing cost of natural gas as high on a day-to-day basis as $9, so 3 times as expensive. People who've not committed to buying natural gas, universities who've committed or not committed to buying natural gas would have had to pay 3 times as much to generate electricity on their campuses, whereas we can still generate electricity at low cost because our source of energy is still priced low. Any questions, thoughts?
So it's domestic gas, but it's going off to other countries, is that why the price goes up?
One of the factors, yes.
But it's all domestic, right? All the gas is aren't always from Mexico.
I believe at that point, a lot of the gas was also being sent to Europe. What type of gas, I'm not entirely sure, but a decent amount, I believe, was being sent over there.
The Russia shipping.
Yep.
Nord Stream pipe.
Yep. Nord Stream 1 was in jeopardy. 2, I think, never saw the daylight, if I'm not wrong. Point being, had we not committed to buying natural gas, had we not locked our prices in, we would have had to burn expensive natural gas, which would have meant that energy prices on campus would have gone up, and somebody would have to pay for it. Now, is that coming down to student tuition? Maybe, maybe not.
With solar would have been stabler, I guess if you looked at it.
If we can generate
You know,
about 47 megawatts, yes. But how much area would we need for that much?
there's a lot of roof on campus, there's no solar panel at all.
No, I don't think we have any.
Like, they haven't even cut the teeth on it. I'm just saying, like, even just as a show.
So work in
Just as a
progress.
Show to say like.
Yes.
Like, well, look at the solar panels, even if they're producing.
Work in
nothing.
progress to going down that way so that we could at least
'Cause you can't really
save
tell
what we
it's really
can and
high.
store it in batteries and use it during the day. Use it as emergency power, use it to charge EVs. Work in progress, but I don't think we're gonna be able to generate enough solar power to power the entire campus. If the panels are on site. If they're off campus, then we're subject to import duties, which limit us from importing it during the day, especially during the summer. So
Yeah, this guy's, I mean, in other words, they can make your house basically energy sustainable with a battery, or on the roof, just on the roof of your house,
the scale though,
So, yeah, but you have a lot more roof, There's a lot more roof that you see than there is in your house.
which is exactly where I was until I started looking at all this. I'm like, it's not that easy.
Yeah, it's not definitely
Yep.
not that easy, but it doesn't seem like there's any effort at all, not even a show effort.
Work in progress. That's all I can say at this point. But going back to natural gas, because we were able to lock in our natural gas prices, or let me put it this way, had we not locked in the natural gas prices, it would have cost us an extra, what, 12 million, 11 million by the end of this year, between then and now. But because we were able to do that, UC was able to save almost $12 million since April 2021, which is cost avoided. And since we were hedged through 2020 or 2030, we're likely to save $37 million between now and then, which could be used for various purposes on campus. Education, healthcare, research, whatever the university wants to fund.
Probably administrative salaries.
At least that I can agree 100%.
administrators.
Yep. The video said 48,000. This says 43, slightly old, but enrollment has gone up. You all know that. And yet cost of energy has continuously gone down throughout various initiatives, various efforts.
I mean, consumptions just follow the black liners have been.
It does. So the black line is enrollment, student enrollment.
Yeah, but-
One would think that it should.
Yeah, but if you had more, say, insulation or whatever, or somehow.
Yep.
Turn the lights off more.
Exactly. So a lot of that is being done on a regular basis, efficiencies within buildings, efficiencies of operation, so on and so forth. Essentially, the idea is what can we do to consume less energy and
Yeah,
what,
like in Europe, if you go to university there, the lights go off in
Yep.
every room, you know, like if you go in at night, it's completely black,
Yep.
even the hallways.
which is something I wondered because I've not seen that outside the
Lit up
US.
at night.
Exactly. What's the point?
Yeah,
At least bring them down, but
definitely the temperatures in the buildings are ramped down too at night in
Yep.
Europe. No. So it's like, there's a lot you could be doing.
I've been in buildings here on campus that are extra cold that you have to turn a space heater on in the middle of the summer.
Yeah.
Why?
I mean, it's hard to control with the cooling system you have.
Exactly, which,
Like,
and stuff like that is being worked on, and that's, and stuff like that is contributing towards keeping the costs
but
low.
still, there's quite a bit of room.
There's a lot,
If
yeah,
someone just took a trip to European University and saw like how it operates completely different.
yep.
That's,
So the hope is to eventually keep improving, and as buildings are being renovated, as new buildings come online, we're putting in more efficient equipment, air handling units, lighting, so on and so forth. From what I understand, the planning, design, and construction office wants to have a minimum of LEED silver. What that entails, I'm not entirely sure from a building standpoint, but the idea is to make sure that all our buildings are that are going to be new and going to be renovated are up to standards, and slowly and steadily, we're also parallelly making sure that our existing buildings are as efficient as possible so that we can keep bringing the cost down, cost of energy down, regardless of the enrollment. I was told it's called 60 by 30, which means 60,000 students by 2030. What are we gonna do about everything else? Now enrollment's going up. Are we gonna increase everything else along with it? You're gonna have another plant. We're gonna have more services, question mark on all of that, but the idea is to keep the red line as low as possible, because if all of that were not happening, this should look much like that and go along with the enrollment, and essentially, in the grand scheme of things, it'll impact student tuition. Our energy costs have stayed constant, I think, for the past 8 years, and the idea is to keep it constant for the moving, possibly another 6 years, moving forward. But because they've stayed constant, again, the university has had the money to use elsewhere, or at least
Somebody's calculated carbon footprint for the campus. How is even considered that?
we are, yes,
So, but it's not a public number?
it should be. I can send you some numbers.
All right, I mean, it'd be good to see the same problem, the carbon footprint. for the
Yep.
campus, like how that-
Very likely, well, I remember the curve from, I think maybe 2 years ago when we did it for a sustainability study that the planning, design, and construction folks were doing. Numbers have gone down. Specifically because we've, efficiencies and all that kept aside, we've stopped buying carbon intensive electricity. We generate more, which is carbon intensive, but turns out what we used to purchase back in the day was more carbon intensive. We've stopped burning coal. That's had a massive impact. So
But they burn, what do they burn on this campus? They burn diesel or something?
natural gas, same natural gas that we burn here.
Yeah, when I first came here, they were burning coal by the
Yep.
football fields.
Yep.
They were, it was basically a coal bunker.
Coal, yep, coal plant here, coal plant over there, so no coal anymore.
Yeah.
So all of that has contributed towards bringing the CO2 down, even though enrollment has gone up, keeping the costs down, even though the enrollment has gone up. Again, like I said, at the end of the day, student tuition is not directly impacted because,
I mean, a lot of it's because coal's price has gone through the roof. So
yeah, and that,
basically, they were driven out of coal. I doubt they would have gone willingly, you know?
or, I mean, you never know.
Yeah, maybe, but see, it's because there's no solar panel, it kind of indicates that they don't care. Like, no, it isn't, except for the water storage is good.
Yep.
That's pretty good.
So,
But that that saves money too, so it's all comes down to the money, not.
At the end of the day, it comes down to the money. Yeah, I mean,
Yeah,
it's,
the carbon footprints in the long term, like talking about the being, but when the students, it's their life is gonna be ruined by the carbon. Right?
Yep.
So you can give them an education, but the world's destroyed.
yeah, exactly. What's the point? Exactly. Yep. But work in progress, small steps. One of the things that we learn in our other energy classes that it's not easy. Sure, we can look at some options and say, oh, that sounds fascinating. We
So
should totally do that.
What is your class anyway, but honors class?
He's pitched now. Honors class on energy Mondays and Wednesdays this fall. Yeah,
Oh, all right, because you can't really advertise, these are all seniors.
yeah. I see a few familiar faces from that class. So maybe once I leave, you could see if
Yeah.
that class is interesting or not. But
Yeah.
point being, yeah, we could talk about energy and everything. We could talk about, hey, we should be doing this, we should be doing that, but practicality and what we can realistically do and cannot do is a whole separate conversation. So long story short, energy at UC, we're doing what we can. UC is doing what it can. It's good, but there's always scope for improvement. There's always scope to do more, and we're continuing to do more. Just that there's only so much that we could do as a university at a given point. So more to come.
I think a lot of it comes from the top down. Right?
Yeah.
You guys want to make decisions.
Yep.
So.
Yep.
Basically, if the students put the pressure on the administration put the pressure on you.
Yep.
But basically.
So what he's saying is you should all be out there.
Well, no.
Yeah. No, which no. Yep.
Except for the coal.
I think the coal part, a lot of the students
Yeah.
at that point
There's
did
a lot
have
of
some
activity
play, yeah.
over at coal.
Yep.
Not a lot. I mean, there was maybe 5% of the students were
Huh.
involved in something to get rid of coal.
Interesting.
It wasn't it wasn't like, Berkeley or something.
Right, yeah.
Basically, the CC will never be like that, but there was a movement to get rid of coal.
Yep.
It did have some impact. Like,
Yep.
It did swing it a little bit. But mostly coal price went through the roof. They got
Yep.
rid of it.
Yep. So as good work continues to happen, UC continues to be recognized for sustainability and energy practices, but all that said and done, awards and all that kept aside, the most important part is that we're able to keep energy costs low so that it does not impact student tuition to the best extent possible. And that's it with my presentation. Any questions? Yes.
So I know you said there's a utility tank under the practice field.
Mhm.
So with the practice field being renovated and stuff, how far beneath is the storage tank underground?
So the one, you're looking at the east tank, this is 50 feet, the entire part of the tank. That's about, top of the tank is about 15-20 feet underground.
Okay.
Same thing over at the main campus. That tank is right under this field.
Oh, it's under that one.
Under that one, yes. I was begging and pleading to see if we could put a tank under the new athletic building, but they're like, dude, no, there's too much money. No. But yeah, so about 10-15 feet under ground level, and then the tank extends further below. The one that we have here is more wide, and the east tank is more tall. And any other questions?
It's a lot of nuclear, huh? And that's pretty good. They say there's no solar panels, and it does make sense.
I'm with you. Like I said, when I was on the other side of the table, I'm like, why do we not have solar panels? Well, we should be covering the entire building with solar panels.
You can just show to say like, who care, Apparently you can make money on it, because people are putting them in, so. Anyway.
My hope is to maybe do something with the Digital Futures building, because that's all supposed to be all
Oh, yeah.
new tech stuff and
Right,
everything.
yeah.
We'll see.
Yeah, that could be kind of self-sufficient knowledge, but you would think they would have thought of that before.
Yeah, so UC's been buying a lot of buildings, which I don't know in the grand scheme of things if we're gonna hold on to long term or not. A lot of it.
Futures give the heating and cooling.
No, they have their own thing. We're not connected down to that level yet, but the hope is to eventually someday maybe connect. We're hoping to connect to Shriners within the next couple of years, Shriner hospitals. We do provide them electricity, but not heating and cooling. So if Shriners is connected, maybe after that, Digital Futures would be the next possible option. What else? Okay, well, that's all
Thanks for coming.
I have. Cool. Thank you, folks. Hope that was worth your time. We could do one. For
Yeah,
sure.
when we went over there, we went through
The tunnels?
well, the tunnel that connects from the plant.
Oh, to the garage. Oh, okay. I mean, we could do the tunnel, which I think is actually right under this building. Yeah, there's one that starts, right in the river show, goes all the way to Networks.
Yeah, we should think about it. I mean, I can get.
Yeah, we'll figure something out. Keep it posted. We'll find something. Sweet. Sweet. Sure. Thank you. I was, I don't know if you probably don't, but way back in 2015. I think I was supposed to be a TA for one of your courses.
Oh, yeah.
Something changed.
Oh, no, I took some undergrad. They were good at it. I mean, they already had taken the
Thank you, yeah, might as well.
So it worked pretty well.
Yep.
And students like to work. Yeah, I do like that.
Yep.
Well, it's good. I had some.
I don't know about that.
I had some that didn't show up. Yeah. All right. Yeah. So you sent a map, right? You sent a map.
How can I take off? Head over there. It's here.
See, I sent it out. We should be back. I'm absorbing the energy. Yeah, yeah. No, it's not the, it's not the raw here, it's in its top.
I'm taking the cord playing you to me.
Like here, if you go back to his talk, which is up.
You're fine.
Like Sean's talk, it's a PowerPoint, but, well, the internet's really slow, but if you go to the last slides of that, oh, I downloaded it. Not that slow. The US power grid thing,
I probably won't.
You know, I don't know.
go down to the bottom of this
Other
somewhere.
things that I'm definitely just not gonna be at.
It's got like extra slides and then,
I want to be invited to things that I'm expected to say no to,
like,
because then I feel great that I got invited, but then I don't have to go, you know?
there's a map in here somewhere. Maybe it's in the other top. Oh, wait, no, that's not it. It's in the other top, right? No, it's under slides for class. It's a Miami Port Power Station, the second one. There's two separate things.
I just, what I feel about being invited to things and saying no, then no, I don't wanna be there. I wanna be there. Hey.
Sean B, Miami Port. It's under all the slide class
That's
things.
not the way to do it. You invite
Right,
them.
that
but,
did
"Oh, darn,
something.
Too bad you can't be there.
I guess this is a coal-fired power station.
Screw you, I'm glad that you. I'm gonna have a honor funeral, it's gonna be bigger.
What are you planning to die?
No, I'm.
Uh,
I'm not gonna die for like another
I emailed
billion years.
the slides from that though.
I'm planning on going out with the universe.
Where is it?
When it goes, I think it's at the bottom of the other presentation.
All right, I looked at the other presentation. This one, right?
Yeah, it's all over. Good luck. Oh, we need to find the address?
No, I emailed it though, right? Do you guys have the email that shows the map or?
I emailed you and you never got back to me. I don't know if you know that I wanted to go.
Okay, that's all right. No, I know you wanted to go.
Okay,
Yeah,
can we just look up Port Miami Power Station on?
yeah, it's like begins with L, the name of it. It's in this talk somewhere.
Like a certain like gate.
There's a sign, you drive, it's to the west of the plant, so it's like you drive past the plant and then there's a sign that says like visitors or something.
Okay.
And then you park there and then you have to walk. You have to walk from there
Is
into
it
the
on
plant.
Powell?
Yeah,
Just look at Fort Miami PowerPoint. Or
Yeah.
Just look at Fort Miami PowerPoint when you look into it.
yeah.
What are the cars in line? What's the plan for cars?
Oh, I don't know. I'm driving
How many people can you fit in your car?
3. I mean, me and 3 people.
Okay. I can't drive.
Okay. Anyone else? Okay, 2.
I can drive if needed. Or
You're driving too, right? Or you're gonna drive yourself? So there's another car if you need.
I don't- We can go, well, can we hop in your car?
What's your name? I forget.
My name's
Kyle?
Kahaya.
Oh, Kahile. Kahile.
Kyle, can we hop in your car? 3 people. Oh, you already taken.
Okay.
Okay.
Did you,
Well, I
all
guess
right, so you didn't find the
wanna-
email? I can get on my computer and find it.
Yeah. It's better than driving it myself.
Fun like slides.
Need a cool car.
Yeah.
If you want, add 3, we can get 3 junior.
But it's,
copies
there's
of
just
these.
a map, there's not, and I put in the Google.
Yeah. Mike, you have some of that? He has. Oh, yeah, it's my birthday. It's my birthday. It's my birthday month.
Would it be sent like as a link or file?
No, it's like a PDF in the bottom of the thing.
Not worth it. I gave my personal notice. If I did wrong. Well, or you can go on. It's too late now. No, I
Just
just got
sent
them all.
this
I also
yesterday.
like a Chick-fil-A entree I can get sometime this month. Why are you that? The Wendy's frosty though, is just, I just have coupons. I got the blue ones.
Also, maybe I didn't send it. Seems like I sent it.
Alright, so we should start going, so we can like.
Yeah, we should get going.
Okay. I didn't.
I can't find it.
Yeah,
I don't know. I think I
run and get my.
I'm sure I sent it.
Right,
Yeah. All right.
Alright. You will there, I guess just like.
What car are you gonna drive? You might be able to like find it
Oh, yeah.
for one time.
Yeah, I got a red pole,
Okay.
so. It's hard to find. Let me kill this thing. All right,